안녕하세요. 텍스트의 핵심을 알려준 토크아이티 세미남 고성PD입니다. 오늘은 2025 퀸 엘리자베스 프라이즈 포 엔지니어링의 수상자들이 얘기하는 AI 탄생의 아하 모먼트를 연결해 보겠습니다. 먼저 AI 대부인 제프리 힌튼 교수의 아하 모먼트는 1984년 역전파로 단어의 의미를 스스로 배우는 작은 언어 모델을 만들면서 지금의 LLM 원리를 세상에 처음 보여준 순간이었습니다. 그리고 페이페이 리 교수는 2006년 기계가 일반화되지 못한 이유는 알고리즘이 아니라 데이터 부족임을 깨닫고 3년 동안 이미지넷을 구축하며 머신러닝의 역사를 바꿉니다. 그리고 이 둘을 현실로 증폭시킨 사람이 엔비디아의 젠슨 왕입니다. 2010년 딥러닝 소프트웨어가 칩 설계처럼 무한 확장되는 패턴을 발견하고 GPU가 AI 혁명의 가속기라는 걸 누구보다도 먼저 보았습니다. 결국 이 세 명의 30년간의 아하 순간들이 모여서 지금의 AI 시대가 탄생한 건 아닐까요?
In about 1984, I tried using backpropagation to learn the next word in a sequence of words. So it was a tiny language model, and discovered it would learn interesting features for the meanings of words. So just giving it a string of symbols, just by trying to predict the next word in a string of symbols, it could learn how to convert words into sets of features that captured the meaning of the word and have interactions between those features, predict the features of the next word. So that was actually a tiny language model from late 1984 that I think of as a precursor for these big language models. The basic principles were the same, it was just tiny.
But it
we had
took
100
40
training
years.
examples.
It took 40 years to get us here, though.
And it took 40 years to get here, and the reason it took 40 years was we didn't have the compute and we didn't have the data, and we didn't know that at the time. We couldn't understand why we weren't just solving everything with backpropagation.
Around 2006 and 2007, I was transitioning from a graduate student to a young assistant professor, and I was among the first generation of machine learning graduate students reading papers from Yang, Joshua, Jeff, and I was really obsessed in trying to solve the problem of visual recognition, which is the ability for machines to see meaning in objects in everyday pictures. And we were struggling with this problem in machine learning called generalizability, which is after learning from certain number of examples, can we recognize something, a new example, a new sample? And I've tried every single algorithm under the sun, from BaseNet to support vector machines to neural network. And the missing piece that my student and I realized is that data is missing. You know, if you look at the evolution or development of intelligent animals like humans, we were inundated with data in the early years of development, but our machines were starved with data. So we decided to do something crazy at that time to create an internet-scale data set over the course of 3 years called ImageNet that included 15 million images hand-curated by people around the world across 22,000 categories. So for me, the aha moment at that point is big data drives machine learning.
아이러니하게도 2012년 이 이미지넷 대회에서 제프리 힌튼 교수의 제자가 알렉스 넷이라는 딥러닝 모델로 압도적인 1위를 하였습니다. 이때 엔비디아의 GPU를 사용하였는데 이것이 결국 GPU 기반 AI 연구에 도화선이 된 것이죠.
Around the 2010 timeframe, simultaneously from 3 different labs, what was going on in University of Toronto, researchers reached out to us at the same time that researchers at the NYU reached out to us, as well as in Stanford reached out to us at the same time, and I saw the early indications of what turned out to have been deep learning around the same time, using a framework and a structured design to create software. And that software turned out to have been incredibly effective. And that second observation seeing again using frameworks, higher level representations, structured types of structures like the deep learning networks, was able to develop software was very similar to designing chips for me. And the patterns were very similar. And I realized at that time maybe we could develop software and capabilities that scale very nicely as we've scaled chip design over the years. And so that was quite a moment for me.
이 세미남의 원본 소스인 FT 라이브 유튜브 채널의 영어 풀 영상은 우측 상단에 카드 링크를 클릭하시면 보실 수 있습니다. 여러분 회사의 신제품이나 서비스 관련 콘텐츠 마케팅이나 웨비나를 진행하는 데 관심이 있으시면 여기 있는 우측 상단에 카드 링크를 클릭하셔서 관련 토크아이티 서비스를 보실 수 있고 관련 문의는 여기 메일이나 전화로 하실 수 있습니다. 테크 전문 채널 토크아이티에서는 AI 관련 다양한 전문가들과 언제든지 상담하고 소통할 수 있는 구해줘 AI라는 공간이 있습니다. 구글에서 한글로 토크아이티 치시거나 우측 상단에 링크를 클릭하시면 됩니다. 여러분의 좋아요와 구독은 콘텐츠 제작에 큰 힘이 됩니다.